Welcome back to Venture Science Podcast, where we meet the founders pushing the edge of science, technology, and what's possible. Today's guest is building something that feels straight out of a sci-fi novel, but it's happening right now. Argo Space is one of our portfolio companies, and they're on a mission to reshape how we operate in orbit. Think propulsion systems, payload integration, and the kinds of modular space infrastructure that could power the next wave of commercial space missions. What makes the story even better, Argo was founded by three brothers, all veterans of SpaceX, who decided to build their own future-facing company with deep technical roots and a shared vision for what space could look like in the decades ahead. And leading that effort is Robert Carlisle, Argo's co-founder and CEO. He's someone who knows what it means to take hard problems and turn them into hardware and do it with a team that feels more like family because it is. In this conversation, we talk about the transition from SpaceX to startup, what it really takes to build in the aerospace sector, and where the opportunities are opening up for those bold enough to go after them. Let's dive in. Robert, welcome to the show.
Hi, Matt. Thanks for having me. Glad to be on.
So you and your brothers all came out of SpaceX. What was the moment that you all realized you wanted to build something together? And how did that shared experience shape the way you approach founding Argo?
Yeah, a very interesting question for us, and I think it goes quite a ways back. My two brothers, Ryan and Kirby, and myself were all at SpaceX together, as you noted. They were both on the engineering side, and I was doing sales and business development. But our interest in space and in building something in space together goes back well before our SpaceX days to our early childhood in Houston, growing up near the Johnson Space Center and seeing a lot of excitement around the shuttle program. We were huge space nerds from the very beginning, and then all ended up studying engineering. And Ryan and Kirby, when they got out of school, they went straight into SpaceX, kind of the coolest space thing you could do at the time. For me, a little earlier on, when I came out of college after getting an aerospace degree, I did missile defense and worked on a program designing missile interceptors, which, at that time I thought was the coolest thing that I could do, but eventually made my way to SpaceX as well. And over the years, we saw all the different pieces of the space industry, both within and outside of SpaceX. We saw how commercial space was evolving, defense and civil space as well. So, the three of us were constantly trying to think of what is the next step? What can our contribution be to this space industry, and really to moving humanity further out into space and expanding, human presence on orbit beyond Earth. So we ended up founding Argo in 2022. Ryan and Kirby were working on a piece of it in Ryan's garage, and then I finally left SpaceX at the end of 2022 to join them to really help take the next step in space beyond launch. As most folks who are listening to this probably know, SpaceX has helped make Earth orbit very accessible. It's pretty easy to get there relative to how it was even 10 years ago. But what we saw is that once you get there, space operations, doing things in space, are still pretty constrained. It's still a pretty fragile architecture for the most part, and pretty expensive. So there's a lot of activity, particularly in low Earth orbit, and particularly with the expansion of larger satellite constellations. But we haven't really seen true industrialization in space. It's still very exciting to see a rocket launch. It's exciting to see a satellite deployment. These are big events, right? So what we want is to create a future where these space activities are just normal sort of background logistics, right? You don't have a big crowd gathering at the Port of Los Angeles to see a cargo ship come in. We want the future of space to look more like that. So that's where we landed on the idea for Argo, which we can get into more what it is. But that vision of sort of normalizing and industrializing space operations and creating these true orbital logistics is what drove us to Argo.
Thank you so much for that wonderful intro. I mean, I know that that's only scratching the surface, knowing what Argo really does, which we'll get into in a little bit. But, aerospace is notoriously capital intensive and it's technically unforgiving. So tell us a little bit more about Argo. What specific problem is Argo solving? And why do you think now is the right time to tackle it?
Yeah, definitely. So we're creating what we think is the next step in space access and utilization beyond launch, which is orbital logistics. So the first thing that we're building are these space transportation and mobility vehicles, spacecraft that live on orbit and operate more like semi-trucks, right? Very different from rockets. Basically dedicated spacecraft to transport things. In the near term, what that means is using these space trucks, if you will, to provide affordable and responsive transportation to unique orbits, high energy orbits, medium Earth orbit, geosynchronous orbit, all the way out to cislunar space, giving customers who are, today Earth-facing customers, giving customers the ability to get out to their operating orbit more cheaply, on their own schedule, and with their own requirements. And that sort of architecture that we're building looks a lot like terrestrial multimodal logistics, where you have the launch vehicle, the rocket, operating like a big cargo ship, traveling the big distance across the Pacific or the Atlantic, and then our semi-truck taking the customer's satellite from the port, if you will, in low Earth orbit out to a higher energy orbit, and making all of those orbits as accessible as low Earth orbit is today. The second part of that, the longer term part of that, is taking sort of the orbital logistics to its logical conclusion, which is not only having transportation in space, but getting the fuel for that transportation in space. So our view is that once we're operating this system, right, we're providing transport on orbit, mobility and maneuver on orbit. Will have a lot of demand for fuel, right? Any truck, any transportation system runs on fuel. And the actual cheapest way to get that from a physics perspective in space is not to source it from Earth, not to keep launching it from Earth, but to source it in space. In our case, we want to source it from the surface of the moon. The shallower lunar gravity well means you get a big advantage, about a 10x advantage in propellant delivered all the way back to low Earth orbit compared to launching it from Earth.
So wait, what fuel? I know the answer, but this is very exciting. What fuel can we find on the surface of the moon?
Yes. So for us, that's water, which is a bit of an unusual fuel. You can use it as propellant in a few different ways. In our case, for using it in space, we can use it in what we call a low thrust or high efficiency system, in a water plasma thruster that we've developed. And separately, if you want to move more quickly, you can use it by electrolyzing the water, splitting it into hydrogen and oxygen gas, and then combusting those in a more traditional thruster. So we think, water is going to be the right propellant for this orbital logistics future, for moving things in space. There's a whole wide range of propellants that we use for satellites today. Hydrazine in some cases for high thrust, xenon, argon, and krypton for low thrust, cryogenic bipropellants. There's all kinds of different fuels today, but we think for in-space operations, water is going to be the right propellant for the future.
So your space trucks essentially go pick up something that's orbiting the Earth at low Earth orbit. So SpaceX or whichever other company takes them to LEO, then you guys pick it up and you take it to wherever they want to go. And of course, as we know, LEO is halfway to anywhere.
Right, exactly.
And so most of the problem is solved, but half of that problem is not solved. And so you guys come in and you guys pick up the payload and move it someplace else with your transport network, and you use water as a high efficient propellant. And then when you run out of water, you turn around, you go back to moon, you land on the moon where there are ice deposits and pick up a little bit more water and then get back to work.
Yep. That's the goal. In the near term, of course, we're going to be launching our water propellant from Earth. But we think it's actually, not terribly far in the future that we'll be able to harvest the water ice from the moon.
Fantastic. So, there's a lot of noise in space tech right now. What do you think people misunderstand most about the commercial space opportunity?
Yeah, interesting question. I think one, as anyone who works in this industry knows, you really need all three legs of the space industry stool, if you will, um, strong space business. You need commercial space, you need civil space, and you need defense. These three parts of the industry fluctuate, but they're all investors and users of space applications and contributors to the space sector. So, commercial space, people usually talk about it in reference to sort of how SpaceX came up, right? With a lot of private investment, building systems to internally driven commercial requirements, and then going and, serving government customers, rather than just building new systems specifically to meet government program needs. And I think that approach has gotten very common, on the spacecraft side, on the launch vehicle side, and in other systems, data and sensors. But you still need all three pieces of the space industry to make a successful commercial space business. The other part is, all of our space applications today are really Earth-facing. People talk about a space economy or a space industry, but the customers for space are on Earth, right? People are using satellite communications. Those people are using it for terrestrial purposes with space systems. Same thing with Earth observation, right? There are some, in space, for space activities driven by exploration goals by NASA, ISRO, ESA, other space agencies. But for the most part, the space industry serves Earth. And so, we agree with that, for today, and that's an opportunity we're still trying to take advantage of, right? When we talk about transporting customer satellites, it means we're delivering something to its operational location, to its work site, to serve terrestrial purposes. In the future, I don't think that will necessarily be true, right? If we succeed and we start delivering a lot of transportation and logistics and mobility services on orbit, we've got demand for lunar water. Now we can turn this terrestrial demand, this terrestrial economy, into demand for a space resource and start creating a real space economy as things pop up around that, lunar resource demand. There's other companies going after similar things, right? Trying to harvest helium-3, for example, on the surface of the moon. But I think that's sort of a future step, is an actual in-space economy versus a purely Earth-facing space economy.
And space is increasingly tied to national strategy and defense. And you did touch on a little bit about Argo's role in dual use technologies. And so, how do you navigate that intersection of commercial and government interests?
Yeah, definitely. I think that's kind of always been a core piece of the space business, right? A lot of government investments and government needs, both on the NASA side and the DoD side, from the early history of this business. But for us, we're building transportation and mobility systems, right? And that has very similar uses in many cases on the commercial side and the defense side. In the US, DoD doctrine for space and otherwise relies on and requires movement and maneuver, movement being more of the logistical piece, transportation, repositioning, and then maneuver being more of the war fighting, what happens when you're actually in contact with an enemy, that type of movement. Those things, the Space Force is trying to prepare for those things being needed on orbit. And our mobility in orbit, our logistics in orbit are quite lacking today. So what we're doing is trying to figure out right now, how do we use these commercially designed, commercially developed systems to provide benefit to the U.S. government as we prepare for, space being more of a government-used, military-used domain with more dynamic operations.
And, of course, you're building in one of the most exciting and most unforgiving industries. Started out with NASA, everything being on the publicly funded, public domain, then switch gears to SpaceX, and now a whole slew of companies, startups on the
Yeah.
private side of things at so many different subsectors of the space industry. So I know you work really hard on the business side of things, from running the business to reviewing building leases to raising capital.
Yeah.
What keeps you motivated on tough days? Tell us a little bit about your your role there, particularly for the entrepreneur listeners.
Sure. Yeah. So you're certainly right. It is a complex business. It is a high risk business relative to your average software startup. Um, but to your beginning point about the early days of this industry and civil space, like what we're building is an architecture that NASA actually originally came up with a very similar thing in the early 70s when they were starting to look at what is the right approach for the space transportation system, which ended up being, mostly the space shuttle. But originally that architecture included a reusable space shuttle, a reusable space tug that lived on orbit, and some other pieces. They couldn't get to that because the technology of the time didn't support it. They ended up making this kick stage called the inertial upper stage. But we firmly believe this is the right architecture, right? Reusable launch vehicles to get things into low Earth orbit, reusable space transportation vehicles that live on orbit. And this is like the thing that will unlock the next step, the next era of the space industry, and let space operations start looking like more like terrestrial operations and open up a whole new set of businesses, a whole new set of opportunities. So that part, yeah, you're right. There is a day-to-day grind of doing fundraising, doing sales, hiring, getting facilities, all kinds of things. But at the end of the day, what we're driven by is like creating this architecture that takes the next step beyond launch and trying to say, we have to push humanity's presence out into space further. We have to help industrialize space, not just make a better widget, a faster thing, a cheaper thing, but we believe we're taking this fundamental step change, in enabling a new space architecture beyond what exists today. And so that's very motivating, I guess, in the daily risks, frustrations, challenges of running this complex hardware startup business.
And of course, you have your two brothers there. It's really rare to see a trio of brothers at the helm of a startup. And I know that you guys divide and conquer. So you
Right.
could talk a little bit about how you guys decided on who does what and who does what, really.
Yes, for sure. So, interesting dynamic. Luckily, my brothers and I have been working on various things on and off for a long time. Whether it was like building model rockets and robots together as kids, or creating Android games as teenagers, and then working together on a few things at SpaceX, to this. So we have a pretty good working relationship, and it is pretty fun. The division came pretty naturally, I would say. So I'm the oldest, and you may guess, listeners, that I ended up being the CEO. I have a little bit more of a broad background across industry, and I think good strategic perspective, and have seen sort of both the engineering side and the technical side. So I ended up being stuck with this job, while Ryan and Kirby get the more fun jobs. So Ryan, he's the middle brother. He's the CTO. He ran a very large engineering organization as an engineering director at SpaceX. He was in charge of big capital projects, designing and building and operating real hardware that helps us go to space. And then Kirby is for sure the get stuff done guy. At SpaceX, his role was focused on reusability engineering, test and integration, so helping figure out how to make Falcon fairings reusable, working on Dragon reusability, refurbishment and reflight, all that kind of stuff. And that sort of along with his personality, naturally lent itself to the COO role. So we've got me going around and doing some of the sales part of the CEO job, as well as like the company strategy and direction. And then Ryan really running the technology and the engineering team, and then Kirby taking care of the operations of the business.
Well, I certainly always admired how positive all three of you guys are working in this space, which is very tough. So, looking ahead, what does success look like for Argo in the next 3 to 5 years? And where do you see the biggest opportunity for growth for you guys?
Yeah, interesting question. So the first thing and the thing that we're charging hardest towards right now is our first launch, the launch of our first spacecraft. And that's planned for February of 2026 on a SpaceX rocket. So we're building that vehicle right now. It's a mission we call the Navigator, and that will demonstrate, our full spacecraft architecture, which is pretty unique, as well as our propulsion system, and it will carry some customer payloads. So really demonstrating the full stack of capabilities, including, the high delta V that we can provide with that vehicle. And we'll use those learnings from that mission to inform, development of our full-scale vehicle, what we call the Argonaut, that has both a high thrust and low thrust water propulsion system. So we'll launch that one, about 12 months after that. So those, big space mission milestones are the most important near-term things. And in 3 to 5 years, I'd say what we want is to have spacecraft on orbit that are regularly serving, all three of those customer types we talked about, delivering science satellites for NASA, providing space situational awareness and mobility for the Space Force, and providing, logistical delivery of customer satellites for commercial customers, and have a future where, in 5 years, in 2030, these things really do look like trucks, right? They're regularly cycling between different orbits. There's lots of them on orbit, and you can really see these sort of roads or trade routes starting to develop with reliable, consistent, unexciting space transportation starting to take shape.
Well, Robert, thank you so much for taking us behind the curtain of Argo Space. It's rare to hear a story that combines technical depth, personal grit, and a truly ambitious and vision for where the space economy is headed. And you brought all three today.
Thanks, Matt. Appreciate you having me on.
And to our listeners, if you're tracking the future of commercial space, defense innovation, or deep tech more broadly, Argo is a company you'll definitely want to keep an eye on. We are very proud to be a small part of their mission, their journey. Thanks for tuning in, and we'll see you next time on the podcast.